Let's get into hot and cold water. I have this little schematic here of, like how I hope we set the table okay that this schematic was something we talked about. And it's not necessarily showing location, right? Schematic doesn't necessarily show where it is. That's a plan view. This is more showing our relationship between things. And so we've got our water line coming in here. We have a little gate valve. We have a water meter. We have a ball valve. And they're saying 3/4 inch line. So we've got 3/4 inch coming over here. And then uh, in this schematic, they're calling it a silcock, but really we're just talking about the um, little thing on the outside of your house to hook up your hose. And so they've got a ball valve there. We'll talk about valves in a second. You got the water line coming in here. So the water line branches off and comes to the water heater. It gets heated up. There's a little isolation valve there, ball valve. And so there is the hot water coming over here. And so the hot water and cold water go different places or go in different lines to, here's the bathtub, it gets hot and cold water. Here's the hot water going to lavatory with the cold water going to lavatory. The point being, I just wanted to show the schematic. I think it's a good deal to be able to show how, like, you bring in something, water, and it goes through a heat exchange basically, and then you have two pipes with the original fluid still being there. It's just that one's hot. Kind of cool. Water schematic. All right, we're looking at the riser diagram, also drawn schematically. And so this is medium-sized project, maybe a little larger than medium. And we've got the water line. So the previous one that I was showing was, sorry, this is just a typical residential water schematic. And this is a larger commercial project water schematic coming into the building. So we've got this 3-inch supply line coming in. Got the main building shutoff valve right here, and we've got water coming over here. It splits in a T. Some water goes this way, some water goes that way. Looks like they've got a drain. They've got these little brackets holding up the piping. And then we've got this thing right here. What's that? Well, it's a little bypass with some valves and a pressure gauge, pressure gauge. And it's just showing if what you can do is, this is the strainer right here. So the strainer is picking up any debris in the water. And then if the strainer is getting full of debris, you can check to see if the pressure going this way, if it's different than if you isolated it and let it go that way, and you'll be able to tell if your strainer's got problems. Anyways, the strainer is pretty cool. We can look at that later. I've got a strainer up here on this line. I have no idea design-wise as to why they split these, but they did, and they have a adjustable pressure reducing valve with 175 GPM at 15 psi drop with a discharge of 70 psi on this line. So we have 75 GPM at 70 psi. G, I'm not sure what the, I can't remember what the G is in psi G. Whatever, it doesn't matter. And then we've got a different amount of psi drop, different amount of water coming through this way. And we've got little things called unions and stuff. But the point is, we'll get into these details. I just wanted to show that commercial, residential, schematic, a little different. And then after this thing right here, on a commercial building, once the water's in, it could be doing any number of things in a commercial building. What kind of building are we at? Are we in a factory? Or are we in just light commercial project that all they really have is it's maybe a little office or something? Yeah, absolutely, it looks like the same schematic as a home. Or it could be very, very complicated. And so we'll cover this side. I just wanted to show the schematic at this point in time and introduce some ideas here of valves, pressure reducing valve, strainer. We've got some drains, to be able to drain this out, keep it to be able to bring the piping down and be able to drain out all the water so somebody could work on it. And then I was going to introduce the idea of a water meter, but I don't have it shown here. But I think everybody knows what a water meter does. So introducing some things. I want to get into valves. And valves is really just basically trying to shut off or isolate a section of pipe. And rather than me try and throw into PowerPoint, I'm going to just go to a website and we're going to show this. Back on the internet, I'm on Ferguson's website and we're talking valves. Look at all the different types of valves. So many different types of valves. Let's just look at ball valves for a second. Super common ball valve. Isolating water, residential, pretty much just going to see ball valves. Can't think it. You're going to see pressure reducing valves, some other things at the water, but that's about all. But look at all these different types. You got check valves, allows one way. Gate valves works a lot like ball valve, but normally we don't need to go through all these details. But the point being, there's a lot of different types of valves, and I don't know that I know them all. I know a lot of them. Larger gate valves like that are on civil water lines all the time. So big commercial water line type stuff, gate valve, more heavy duty. Anyway, backflow preventer, steam traps, relief valve, globe valve, plug valve. I don't know what a plug valve is off the top of my head. That's like your outside hook your hose up to something. Wall hydrant, well, that's kind of the same thing as a sillcock. And hose bib is actually kind of the same thing. But it doesn't matter. My point is there's all kinds of things. And you'll see these on different commercial projects. And I've tried to become myself, like I said in the past, a student of the industry. And if I see something new on a project, I usually come to a site like this, look it up real quick, and add a little bit to my knowledge. I want to know a little bit more. So knife gate valve, don't know what that is. Maybe that's on my project. We'll go look and see what a knife gate valve is real quick. Oh, yeah, sure. All right, right on. Hook up to a flange. That's pretty cool. Different system. Designer calls for a knife gate valve. I know what a knife gate valve is now. All right, valves all over the place. Moving on to plastic water pipe. Super common, both residential, light commercial, and multifamily. Super common. And this is what you'd expect to see on the basic materials, right? You've got some plastic pipe, and these are the fittings to join to. This would be joining two sections of plastic pipe together. This would be making a 90, right? You have a little thing to be able to pound this into a stud wall, and the pipe can fit in there. So you pound this thing into the stud wall, and then clip the pipe into there. And this little thing right here that is used with this tool to seal up the different ends. So as this fitting goes into there, this guy right here, this little thing gets crimped on and tightens down around it, keeps it. So this is a manifold, right? So we were just looking at a pretty common looking manifold here as an example of what you'd see in a residential or light commercial environment, or a multifamily, and some of these are going to this unit and some of those are going to that unit. So you can see these manifolds in multifamily too. Anyway, all kinds of stuff right here. But you got the hot and cold and hot side, and you can kind of see that. So we've got the just off their website here. I don't know how to say that, actually. I'm wondering if this is, um, I wonder if I pulled this off of like a European way of doing this. A lot of these are different styles. I don't really care. It doesn't matter. There's a ring on there. There's all kinds of different systems on how this is actually joining together. Maybe this is the one. Maybe it isn't. But usually you have some sort of pliers looking mechanism, and it can crimp this thing down, and sometimes it's something that looks like that, sometimes it doesn't. So that's your plastic water. It it expands and contracts. So in hot water, you're supposed to like add a little loop before you make a 90 or go somewhere else. You're supposed to add some more. So you're not supposed to do this very tight. Is kind of the point. So that's one material method of moving water around, and these come in different sizes, different size pipes, but usually it's like 3/4. And so moving on, we've got copper as a water conveying, and copper has different wall thicknesses and stiffnesses, and you have K and L and M and all different types of copper piping. I'm not interested in sharing all the details about the different types of copper piping. Just know that there's copper pipe is one option for conveying water, uh, and I think it's type L that goes underground. I think joined by soldering is usually, or you could braze, or you could do a compression fit, or you could do a mechanical fit. There's all kinds of stuff there. And what do you need to do before you cover it? Well, you need to test it. And I use this thing again. I shouldn't have, because that's not what it looks like. Usually you just cap it and put a little, um, well, you'd still use something like that in the end, but basically fill up the pipe with water or with air and pressure test it for a period of time. Usually, like the IRC, I even put it in here. IRC is 15 minutes of working pressure. So if we had that pressure reducing valve set at 70 psi, then we pump this thing up to 70 psi, wait 15 minutes, and make sure that it held at that pressure for 15 minutes. It didn't drop down. So I brought this up last time. I'll say it again. Like if I was talking to the plumber saying, when are you going to be done with the water piping, I would not say, when are you going to be done installing piping? I would say, when are you going to be done installing piping and fully test it out on such and such floor. One of the big deals that I think I was never taught in school, but is a huge problem, is water intrusion and damage by water. So our industry, I think some of the biggest losses I know of, on a construction projects are dealing with water intrusion. I have a little thermal imaging camera showing this here of like water just coming down. This is FLIR's website picture. It's not mine, but been on projects before where we brought out in cameras like this, and you can see, oh my goodness, this wall is completely saturated in this area. And tell the difference in temperature, and just big losses and going backwards due to water. And why does that happen? Well, one of the things that I was just showing was that PEX and the crimping, and I've literally seen it where uh, the plumber is able to pass a test on PEX with certain types of fittings that have a nice bite to them, but still require like the ring to go around, and the ring is not tight. It's just sitting there, not crimped, and it passed the test at working pressure. But over time, that pipe worked itself loose, and tons of water into a unit. And then where does water go? It goes down, damages everything down below it. Keep going down, keep going down. Water intrusion is huge. So on a project, this has been ingrained in me from I would say I learned this over the last like 5 years, dealing with some of the insurance folks and how big of claims can happen. But really got to be paying attention to Is your piping really tested? Do you know where your isolation valves are on a project? Are you shutting water off during the end of the day? Um, Things like that limit your risk associated with water from piping. So this is one that I wanted to share. This is another example of water intrusion, and this right here is the vertical waste stack. And what is that? Well, that's a drilled hole, and we're actually looking at in a closet. Look at that. There's two layers of 5/8, so this is a fire rated wall. Walking through the so I'm jumping into the picture and not talking through my slides, but the point being, somebody drilled something in the closet, and I know what it was for. Is for the shelf system, and there is backing there for the shelves. But to try and put something in here, it wouldn't have mattered what they did; they would have drilled right into the pipe. And so this is unfortunately common. And knowing where your piping is a big deal. So I really like marking the lines on the floor if possible, just with some green marking paint, saying, okay, coming along, that's where the main stacks are of the building. And if they can be pushed back farther into a cavity, that would be ideal. But if they can't, I would definitely mark them out. And then as part of the work and coordination, let people know what those markings mean. Go follow up the individual tradesmen as I walk through the building. Say, hey, do you know what that means? That means there's a pipe right there, so don't screw anything into that right there. So we've got another way to protect piping, and it's super common. Is you've got like multiple rooms next to each other, whether it's a hotel or multifamily with all these piping. Multifamily, I keep bringing it up, but there's so many of them going on right now. Apartment buildings and different things like that. And the tradesmen walking through the framed walls, meaning there's no drywall up yet, so they can walk through. And a lot of times it damages the piping, or you get nicks and scratches on the piping, or you snag your foot on the piping, crack it, whatever. Same thing with electrical. It damage your wiring as well. Protection plates are a big deal. So if you had a stud, anyway, I think protection plates. People, if you don't know what that is, Google it real quick. All right, let's move on. We've got roof drains. I've talked about this in the previous lecture, but I pulled out a good detail this time to try and show it rather than me draw it. And we've got this drain body right here with a basket over it. And so this basket collects the lighter debris from getting down into here. And we've got this drain body right here, and that is attached to the decking in this case. And then we've got piping coming over this way, and we've got roof deck and insulation. And they said that they build this little area cut out so that the water will definitely come into this location. And which one's the primary, which one's the secondary? Well, this one's the primary because it's lower, and this one's the secondary. So this one's going to go into the storm drain usually. And this one usually daylights out onto a surface on the outside of the building. But one of the things that I want to talk about from a coordination standpoint is imagine your building and what has to be done. Think through this sequence, right? So you're going to build up. You go floor by floor, or maybe it's only a single story or whatever, right? Well, these drains have to be in before you can connect them to pipe, right? And the roof has to be on before you can really make these drains useful. Did I say that right? The drains have to be in and the roof has to be on and tied in before the roof drain is useful. But let's say, then this is super common too, and it's a challenge because you got to sequence it. But you get this roof done, and you've got the roof tied into this drain, and say the plumber's not on site, maybe he's got a little bit of a gap and you've got no piping right here, and you get a rain event. Well, the roof now collects a ton of water, goes right to these roof drains, and just right down, concentrated. Now, probably not all going to damage a whole lot, because if you're just barely getting a roof on, you shouldn't have a ton of finishes down below. But think of it like a warehouse where you've got a large area of the floor is not placed with concrete yet because you don't want to damage it. You want to place the floor last. And so, and these are all up, and you're trying to do earthwork or something down below. You get a large rain event coming right here, and then you have this large concentration of water that happens. And so I'm just thinking through you get a big disturbed area of the area that you had all prepped and ready for concrete because we didn't have these things connected yet. So super critical. As soon as you get these things done, have the plumber right there, have the plumbing piping all ready to it, so they just have to make this connection. One other thing that's pretty common is that the primary, remember the primary usually goes to the storm drain, but what if you're on a project that the storm drain is not completed or the storm drain is not connected to the building yet, meaning the new infrastructure around the site is not done yet? This pipe is going to go down below your footing and foundation and then end at outside the building somewhere, capped, hopefully. Well, you can't just let this thing fill up with water. That would be a bad thing. That's not meant to do that. So a lot of times folks will swap it, and so they'll make the primary hooked up to this pipe over here. If the infrastructure is not ready for this, they'll hook up the primary to the secondary pipe. And so if there's a rain event, the rain goes out of the building, but out at daylights outside the building and into where the secondary roof drain would normally go. And you just got to remember to swap these back. And I've seen it before in warranty where we didn't do that. Okay, let's go trace this out on a larger project. Looking at this, I'm on the plumbing drawings, and we're looking at the roof. And we see here we've got RDS1, RDP1. And let's go look at the notes, 1-1. Route roof drains the floor below in this approximate location. And remember, I've told you before that certain designers, their information governs. But I love that the engineer put this on there, because this is probably not the exact location of the roof drains. He's just drawing them schematically. There's two sets of them on the roof. And he was saying, even in the note, this might not be the exact location. And so if you look at this line right here, most likely this is the overlay of, I don't know. Anyway, this could be actually the low location of the roof. And don't know what that is. But anyways, it doesn't matter. We're not here to look at whether there's a conflict with the roof. The engineer did a good job. So here we are. We're looking at this. We're on roughly between grid 6, 7, 8. There's another one over here. There's another one over there. So let's go look at that. Let's go down a floor. Okay, down one floor. And now they're showing the roof drain. So they're showing those two, one primary, one secondary. Which one's primary? This one. Secondary. Remember, this is shown, there's another set right here maybe, because he showed two sets. And the plumbing is going this way. And then it's going down, right? Down. Those are round. So what's note 4 say? Route roof drains to floor below in this approximate location. Fill, verify exact location. Another good job, Mr. Designer, in my opinion. All right, we're coming down, and that is grid roughly D.5 plus, I don't know, or minus, so maybe grid line D roughly. It's not D.5, so somewhere around there, and grid 7 is where it goes down. So we need to go down a floor. There we go. All right, grid D, which is about right here on this arc, and grid 7. Oh, there it is. So there's our grid D, and there they are coming down. Primary roof drain, secondary roof drain coming down from the floor above. So it went from the roof. If we were trying to, it came from the roof up over in this area, came down like that, over here, and then down. So that's the round thing. It means it's went down. And the primary is coming over this way, and the secondary is doing that thing. So the primary is going over here, and it looks like right there to me. Note, let's see what this one's doing. Yeah, this one, secondary, is coming over here, crosses over, goes down. So primary is 1 and secondary is note number 2. Primary. So it says see civil drawings for continuation. Provide downspout approximate location. All right, cool. We traced it out. Hopefully you're following that all right. Just trying to over communicate a little bit and give you an opportunity to trace out a pipe. See where it's going from floor to floor to floor. And using grid lines to try and pick up where they go as they go vertically between the floors. Try and get a view of that. We could go into our model and we could trace it that way. Let me back up, sorry. Where am I? Oh, no, that was it. Let me go over this way. Try and orient it the way the drawing showed. Yep. Saw those 2 roof drains. 2 sets of roof drains. You see the piping. And this is the actual BIM location of what we're doing. Kids are coming. If they come in here, I'll have to stop and restart, but they're out there having a good time. Hopefully you can not making too much noise for you. And there it is right there, following it along. So see if we can get on that. Looks like it comes over here. Yeah, there it is. It got into that cavity and it's going down. Let's go try and get over it. A little better view. Well, I don't know if I'll be able to trace it. I should probably turn off some layers. Forget it. It's all right. That's all I wanted to do is try and show that your drawings here were showing one thing. We went into full coordination mode with the drawings and got it out of Navis, and then we were really detailed there exactly how that was getting there. So tracing that all out. All right, moving on past roof drains, but I should have brought this up prior to when we were still talking about plumbing, piping, and kind of like that rough-in phase. But that's all right. Got this little area cut out of the building that shows a restroom, toilet room. And you can see like these grab bars right here. And this grab bar right here. And it doesn't necessarily say that the toilet room is ADA compliant, but one dead giveaway of where the ADA compliance is See this circle right here? When you see like these dashed circles or squares that don't sort of like make any sense, well, those are the spaces that the designers put in there to ensure that the ADA compliance is there. That's a 5-foot turnaround for this area. And look at that, 1 foot 6 inches. Guaranteed that dimension is right there because of ADA compliance. And so the point is, as you look through different rough plumbing, definitely on the job site, definitely pay attention to your ADA rooms. Know where they are. Know exactly what the dimensions have got to be. Go get yourself a little ADA card. I think you can get them off the line for $5-10. Who knows what? Little cheat sheets that they sell. And you got to know exactly where this stuff goes. So this is 1 foot 6, and the plumber needs to make sure that this hits exactly right. And I don't remember what the I need my go pull my own little card out and see what the tolerances are. Usually an inch. Okay, cool. ADA stuff. So we've got this. This would be ADA compliant stuff, but I'm not bringing it up. I'm just talking about got to pay attention to ADA when you're doing rough plumbing, plumbing waste, plumbing drain, plumbing piping. One thing that I don't have shown that's worthwhile is if there's no cabinet down here and somebody can pull up, typically they can pull up a wheelchair underneath here, the piping has to be insulated so that say hot water is in that pipe and somebody nice person is in a wheelchair, comes up and gets their knee on that drain, and it's not burning them. All right. Fuel gas, natural gas, basically. We got a residential gas system here that's a schematic in nature, and elevation view, sort of, right? This is an elevation view of a gas meter. Hopefully you've seen these before, but basically you've got the gas supply coming in here, going through a little shut-off valve. Got a little sediment trap because these pipes corrode, right? So they don't want any sediment that's any little particle to get into the meter. So they create this little area for it to collect down here. And they have a little shut-off valve here, and it's going through the meter and into your house. So we got the meter coming in. It's 3/4 line to the house. Who knows what these numbers really are on your home or whatever, but going to the water heater and to the furnace, and there's all kinds of stuff that you need to feed, right? So the schematic, typically meter, valves, pipe. That's what you're going to end up having. But there's all kinds of stuff that you could be going to, right? What else would you feed in a residential environment? Well, fireplace, you could have gas in a stove. You could have a dryer. You could have outdoor fire pit. I can't think of anything else off the top of my head, but there's lots of little things that you could have. And so usually on the residential side, you could get your mechanical contractor calc out plumbing size and whatnot. But again, it has to be tested prior to getting a meter set and inspected. And so similar things as before, I would never ask the mechanical guy running the piping, when's he actually going to install the pipe. I would ask when he's going to be ready for test so that we can be covering it up or ordering a meter or whatever the case may be. Now on the commercial side, the gas stuff is more complicated, so we're going to cover that in a future lecture. Not going to cover not going to cover that here. Okay, hydronic piping. This is the floor system is usually something similar to this anyways, but a manifold, so I just copied this exact drawing. It's usually some sort of plastic piping and some sort of manifold. Now, let's go look at Ferguson again. I already did ADA. Yeah, let's go look at Ferguson for other types of hydronic piping systems, okay? No, I'm serious. Got to be really quiet. All right, I'm on Ferguson's website looking at hydronics. And so you've got these different components here, and I'm hoping in your mind you can say, okay, we got some components, and we have piping, we have valves, we have all kinds of little things to be able to convey water around, hot water, to be able to transfer heat. And so let's just go look at some baseboards. We've got a boiler, piping. What's it going to? Oh, hey, you've seen those in homes before and in commercial environments where what's that thing? Oh, it's hydronic heating. That's what that is. All right. Let's go see if we can look at it. Check that out. All it is a copper pipe with a bunch of fins. And what is the fin doing? Well, all it's doing is transferring heat to the air. More surface area to be able to move the hot water heat into the air. Okay, cool. Got that. Thanks for joining with me today. Thanks for joining with me to class today. Appreciate you. And we'll see you next time.